Hello, everyone. Welcome to the third lecture in Introduction to Data Science. Today, we will continue with the Python review. So we will get to know things about string methods in Python. So we're going to start with this example here. We are defining a string. Okay, so text is the name of the variable. Text is equal to this string since it's multi-line. So we have 3 quotations from each side. So we define text as this very long string. And now we're gonna play with that. Okay, so we're gonna try applying different functions to it. So we start with the first function. So we call the built-in function split. So this function is in the class string. So since text is a class, then we call that function by using text.split, and we're passing the dot character. This will break this long sentence into a number of sentences that's equal to how many dots are there, +1 actually, because last one, if we run only this line, if you don't add this line here, then we're gonna break this sentence by how many dots are there. This is the first occurrence, this is the first dot, so this will be the first element. The output here, sentences, will be a list of strings. Okay, this is the first string, this is the first element, the one before the first dot. This is the second element, the one after the second dot. This is the third element, which is a string, okay, before the third dot, and there will be another port 1, which will be empty, okay? So there will be an empty element at the end. So in order to get rid of this empty element, we call the function pop. Okay, we pass -1. -1 refers to the last element. So we're gonna remove the last element here. So if we print it out, then we will have 3 elements. Okay, we have the first string here, the first element, okay? And then the second one, we have the /n, a new line. So this is for enter, or the new line. So this is a special character because we're moving from this sentence to this sentence. Okay, we actually have a new line here. So that's appearing here. So we have /n here and /n here, okay? We will show later how we get rid of these, okay? The default, if we don't pass, it's still gonna do the same, because actually the default call for pop will just remove the last element. If we, for example, write -2 here, then we're gonna remove the last 2 elements, the empty character and the last sentence, okay? Now we come to this one here. So what are we doing here? We are going over every sentence and sentences, every element in the list sentences, okay? We're going over every element, over every string, and we are applying these functions, okay? These functions will be applied in order. So we actually calling the function strip, which is gonna, this function is going to remove any leading or training spaces as well as special characters. So it will remove the /n. Then dot capitalize will capitalize the first letter of every string, and dot replace will replace this, whatever we pass first here, with this. So here we're replacing ISE, the small character version of this word, the one that uses the lowercase letters, with the uppercase letters, okay? Because this is actually meant to be abbreviation, okay? And then we add a dot at the end. So if we run this cell, this is what we get. The special characters are not there anymore. And here the first letter of every sentence is capitalized, okay? There's one thing to mention. We can actually, this is a very compact, concise way to do it. We can do it in different ways. This is, for example, this one here, okay? So we are starting with an empty list, and then we're going over every sentence and sentences, and we're applying this function one at a time. So we apply strip first to get rid of any leading or trailing special characters and spaces. Then the output is, then for the output, we apply capitalize to do capitalization and so on. Okay, yeah, that's another way to do it. Okay. So yeah, I don't know why I have this here. I don't think this is part of the original slides, but actually this join function takes a list. Now we have a list of strings, and it will join it will do a join between this string, and it will actually insert this after every element in this list. So we are inserting back the new lines. So that's what happens here. Okay. Let me just first run the complete thing, because actually here. Okay. So we will go back to 3 lines when we run this. Okay, 3 lines. Okay. Okay. That's about strings. Now we come to some special functions in Python. We're going to talk about lambda and the lambda function and map. Okay, lambda is a keyword actually. It's it defines an anonymous function. You can define it in the middle of the code. This function takes any number of arguments, input variables, but it can have only one expression. Okay, so with example, it will be more clear. So let me just first define it, and then we're gonna see a use case for it that will make it clear. Map is a function that takes 2 things. Takes function, the first argument. It's a function, takes another function, and it takes the second argument, an iterable data structure, like a list or tuple. Okay, and it will perform. So it takes a function, and it takes that iterable data structure, and it will apply that function to every element in that iterable data structure. If it's not clear now, it will become clear when we come to the example later on. Let me first start with lambda. So this is an example, show how lambda works. So it's a keyword. When you pass that keyword, when you write it, then what comes after that keyword is a function. This function takes x as an input and returns x squared evaluated at x equal to 2. So like, for example, if you have a function that you need to call many times in your main code, then it's better you predefine it once, and then you can call it at different places in your code. But if there's a function that you use only once, then you don't need to predefine it. You can just use the keyword lambda, and then you define your function and evaluate it at whatever value you want to evaluate it at. So this is the output. So it takes x equal to 2, then it will return x squared, which is equal to 4. And this is the format. Take the variable, colon, and the function. It can also take more than one variable. Like here, it takes 3 variables, x, y, and z, and applies this function, x plus y times z. It's evaluated at x equal to 5, y equal to 6, and z equal to 2. It can also take a condition like this one. So here, lambda, we have input variable x, and this is the function. So this function is what? So so it's going to print x is an even number if x is even, if the remainder of dividing x with 2 is equal to 0. Otherwise, it will print that x is an odd number. And since we are passing 7 here, then what will get printed out here is 7 is an odd number, and that's what we get. And this cannot start with a condition. We cannot take this if here before. We cannot put it here. If we do that, we will get an error. Now we come to map function, okay? So in order to explain how it works, let's look at this example. Here we define a function. That function takes any x and returns x squared. Okay, this is a predefined function. And here is our main code. So we define a string, we give it a name, numbers, that's equal to this, okay? Now here, if we wanna square every element in this string, this is a very nice way to do it. So we call the function map. We pass our function here, this function, which takes x and returns x squared, and we pass the list number. So these are the 2 arguments. This is a function, and this is a list. We pass these two to map. Map will perform this function, will apply this function in every element on numbers. Okay, and then as we can see here, the output of map is passed to the list function. So the outcome, the final outcome squares here is a list, where each element is the square of the corresponding element in this list. So it will be 1, 4, 9, and so on. Okay. Now here, again, so as we said, map takes function and a terrible data structure. Okay, here it's a list. So this function could have been predefined, as well as we can define it here. Okay, as you can see here, we pass the keyword lambda, and we are defining the function here. So this does the same job as this one. So we pass this is the function, this is our function. Okay, we are still passing function and list to map. So this will perform the same thing, and we get the same result. Okay. We can also pass more than one list. We can pass two lists, and we define a function. Okay, for example, here, the function we are defining is what? So we're passing the keyword lambda, then the function is just defined here. So it takes x from list 1 and y from list 2, and returns the difference between x and y. Okay, so the difference between this and this, here we pass list 2 before list 1. So here, actually, we're taking list 1 for the first example, list 1 minus list 2, and here list 2 minus list 1. So every element, for the first example, the first element would be 1 minus 5, second element 2 minus 5. For this one, the first element would be 5 minus 1, second element would be 5 minus 2, and so on. Okay. Okay, so we can also, the function can also have a condition. Okay, like this function here. Okay, so here we're defining a list. We are creating a list. This list will take numbers from 0 to 10. And then we are passing that list and this function to the function map. Okay, so what will happen here? This function does what? It takes x, where x is taken from numbers, and square that x only if x is even. Otherwise, does none. Okay, does nothing. Sorry. No. In fact, replace the odd value with none. Okay. So then, what will happen here? If we print out this, then the first element is 0. So it's an even number. Then we will have 0. Then one is an odd number. So we will have none there. That's for the new list squares. Okay, numbers is as is. We are creating a new list here. So the first element will be 0, second element none. The next element will be 2, and the one after will be none. Okay, let me just print it out to look at here. This is what you will see. But actually, a more efficient way to do this, if I don't want to include the odd numbers, I can first exclude the odd numbers, as we do here, because this is all the output of this is also a list. Okay, we can take only even numbers from the list numbers. So x for x in numbers such that x is even. We are taking only those, and we apply this function to only even numbers, and we are creating a new list from that. That's why you see here only the even numbers. Okay, the squares of the even numbers in the numbers list, and the odd numbers are already removed from the original one, so their squares do not appear here. Okay. Now we come to NumPy library. NumPy stands for numerical Python. So as the name indicates, NumPy arrays take only numbers. They don't deal with strings. Okay, so we import NumPy as NP, and we're gonna work with NumPy arrays here. Let's come to this. All these things, we will be doing them one after the other in the coming cells. So let's just go right away to the cell to use the time very efficiently. So here we call the function function zeros. Okay, np.zeros, and we're passing a number here. What are we doing here? We are creating one-dimensional array where all elements are zeros. And how many elements are there? There are 10 elements. Okay, A here is a NumPy array. Okay, so we can Okay, so let's look at these two things here, okay? We can actually create a list, and from that list, we can create a new array. How we do that? So here is how we do it. We can first, we can first create a list of zeros. This is a list of zeros, 0 for x in range 1 to 10. So we're gonna have 10 zeros, okay? And we are creating a list from those. Whatever we pass inside these two brackets will be an element in the list. So we created a list here, okay? We can print the content of that, and we can check the type. It's a list, okay? Now, we pass that list to the method or the function np.array, okay? So this will take, this function takes a list as an input, and from the elements of that list, it creates an array, NumPy array. So if we print the type here after, before and after, as you can see, the first one is a list, the second one is NumPy array. And by default, the data type for an array will be floating point, okay? If we want the numbers to be integer, then we need to pass the word int here. So here we are creating a two-dimensional array, 2D array, where all of the elements are ones, okay? And the size is 3 by 5. So the number of rows is equal to 3, or the number of elements in the first dimension is equal to 3, the number of columns equal to 5, or the number of elements in the second dimension is equal to 5. Okay, so we have 3 rows, 5 columns, and the values of the elements are all ones, and they are integer. So if we print out this, as you can see here, the elements are integer. Okay, if I don't pass this, or if I pass this float, then we will see the decimal point here. Okay, so they are floating points. Okay, the type now is a floating point. Now we come to another function, np_full. Okay, it takes shape and value. So we want to create an array, two-dimensional array. Okay, number of rows is 3, number of columns is 5, and every element, so every element in that array is equal to np.pi. It will be 3.14 whatever. So it's a long number. Okay, so we are filling all elements with pi. Now, the second one is doing the same thing. It's taking the shape and taking the element, but here we are just rounding. So we're taking np.pi and we round, and we consider only 3 elements after the decimal point. So the last element will be rounded. Okay, the third element after the decimal point will be rounded. So then this will be 3.14 2, for example, for this one. This is 1.5, it will be 3.142. Okay, this is the first 2D array, and this is the second 2D array. Both are filling the elements with pi. Here just rounded by after rounding the numbers here. Okay, now we come to another interesting thing, is how to generate random numbers in the elements of NumPy array following a certain distribution. Okay, so let's look at the first line here, np.random.seed equal to 0. This is just, we are passing a fixed seed. So if we run this cell again and again, many times, every time, the numbers are taken from a random distribution, but the numbers will not change since the seed is fixed. If we run this again and again, we're going to generate the same set of random variables. They are random variables. They are taken from a certain random distribution, but since the seed is fixed, if we run this cell again and again, we will always reproduce the same numbers. Okay, so now let's look at this function here, np.random.random. Okay, so np.random, So we are calling, we are creating, generating random numbers, but here we are specifying under what distribution. So this dot random and this dot rand n, the size is same, 3 by 3 numpy array in both cases, but here the distribution is taken from, we're passing the keyword random, and here we're passing the keyword random. The difference is that here we're going to generate random variables, okay, but they are generated from the uniform distribution. Here from the normal distribution, they follow normal distribution or the Gaussian distribution. Okay, what do we mean by a uniform distribution and a normal or a Gaussian distribution? So let me explain it maybe here. Let's just share. Okay, so this is a normal distribution between 0 and 1. So this is a normal distribution. This is 1 and this is 0. Okay, this is X and this is P of X. Okay, it's not so. Okay, so every element here, every number here has, all of the numbers have equal probability to be selected. So that the word uniform, where it's coming from. So it's a uniform distribution. They are all equally probable. Okay. Now the normal distribution or the Gaussian distribution, let's do the Gaussian distribution with mean 0. This is a Gaussian distribution with mean 0. Okay, this is 0. So the mean or mu, which is 0 in this case, has the highest probability to be selected. And as we go to the right or to the left, the probability drops following this curve. Okay, mu controls the center of this distribution. For example, if we have a Gaussian distribution with mean, for example, 10, then the center will change. Okay, so this will be centered around 10, but the shape is still same. Okay, what controls the wideness of this distribution is the variance. So higher variance will lead to a wider curve. Smaller variance will lead to more narrower curve, like a narrow curve like this. Okay, it's not perfect, the drawing, but I think you got the idea. So mu controls the center and sigma square, the variance, okay, or the standard deviation, which is the square root of the variance, controls the how wide the shape is. Okay, so actually here this distribution for any x, p of x is equal to, let me write it here, 1 over square root 2 pi sigma e to the minus x minus mu square over 2 sigma square. You clearly see that the highest, so when x is equal to 0, we get the highest probability because, sorry, when x equal to mu. So when x equal to mu, then this equal to 0. So this equal to 1, which is the highest value, then we get the highest probability. And as we deviate from x to the right or the left, the probability goes down. Okay, let's go back to the slides. So random will generate random variables following the normal distribution. This will generate random variables following the uniform distribution. So for this one, the values will be between. Now, the default, if we don't specify like anything, then the default here, it will be a uniform distribution between 0 and 1. And here it will be a normal distribution with mean mu equal to 0 and sigma standard deviation equal to 1. So that's why you will see now when we print this out, these numbers here will be positive, greater than 0, between 0 and 1. As you can see, all of them are positive between 0 and 1. while for the second one, we see some negative numbers because there are negative values, because 0 is in the center. We could choose numbers that are less than 0. So here we are repeating the first one, but we're just rounding because after the decimal point, we have many numbers here. So we're just rounding. So we are only considering 2 digits after the decimal point, where the second digit is a rounded version of whatever the second we have here. Okay. Now we come to generating random numbers, but random integer numbers. So we call the function rand int. And here we are specifying the starting and the ending points. So we are generating numbers between 0 and 10, but we are only considering the integer numbers between 0 and 10. Okay, 0, 1, 2, 3. And from those generated numbers, we are creating a random, we are creating an NumPy array, 2-dimensional array of size 3 by 3. Number of rows is equal to 3, number of columns is equal to 3, where all the values are selected from integer numbers between 0 and 10 with equal probability following uniform distribution. So choosing any integer number between 0 and 10, all of these numbers have the same probability to be selected. They are equally probable, but integer numbers only. Okay. This mp.i3, this is generating an identity matrix of size 3 by 3. Last one, mp line space 0, 1, 11. So this is from where we start, this is where we end, and this is how many elements we need to consider. So we're gonna generate numbers between 0 and 1, and we want to generate 11 numbers. So line space will actually take this as the starting point and this as the ending point, and it will return in total 11 numbers, such that the step size is the same. Okay, the step size of moving from the step between, like the distance between the number and the next one is the same. Okay, so this is what we get here. So you can, so if we are moving from 0 to 1 and we are considering 11 steps, then the next element after 0 will be 0.1. Okay, 0.2, and 1 here is inclusive. As you can see, 1 is there. Okay, so for example, if we choose 10 steps, okay, then the second element will be 0.11, right? 111, and so on. Okay, last element has to be this one. First element has to be this one, and then the distance between any two between an element and the next one, like between any two elements, consecutive elements, is equal here. Okay. Okay, that's it for today. We will stop here and we will continue next time, inshallah. Assalamu alaikum.